Hey kids, Smath here. Part 4, weak base, strong acid titration. We're going to hit the equivalence point. This one's got a little bit of work behind it, just as easy as that midpoint was last time. So let's take a look-see. We're going to reach the equivalence, and by definition, that's going to be our word equimolar amounts here. So in this case, all the H reacted with all the phenolate, the OC6H5. What that's going to do is make 5 times 10 to the negative fourth moles here. Now, we need to find that concentration. And I'm just going to tell you right up, excuse me. We had 50 mils to start with of the 1 molar. We're going to need another half a mil. So our total volume here, 0.0505 liters. So my concentration here is 9.9 times 10 to the negative third molar. That's of the HOC6H5. Now at equivalence, all we've got is product. We just finished the stoichiometry of this. So now we got to let the equilibrium take over. Let the acid-base equilibrium do its thing. So flip the reaction and run this backwards now to find out how much H plus is going to split off of this and what our pH is going to be. We know it's a strong acid with a weak base, so the pH has got to be below 7. Let's prove it here mathematically. Nothing, x, negative x, 990 minus times 10 to the negative third minus x. You guys know the whole deal here. This is still going to be an ass x neg, x squared, 990, 10 to the negative 3 equals the Ka. Now, how did I know that had to be a Ka? Here I've got an acid up front. I'm going to use a Ka. Over here, I've got a base up front. If I was using this side of the equation, I'd be using Kb. The way I look at it, I always want to have my acid dissociating, but if I have to have my base dissociating, this is what it looks like. Add some water, let it go, it's all going to be good. Right now, this is what we have, and that X is going to be equal to the concentration of H plus, and I've already done this. I've checked my assumption. Everything was valid. Everything was good. Our X is equal to 102, 10 to the negative 6. My pH here ends up being 599. Look at that, just a wee bit below 7. Not too surprising, right? We had HCl, a strong acid, neutralizing this weak base. We also kind of knew that from the Ka values. Ka here is 10 to the minus 10th. This is a lousy acid. This is a lousy acid. The Kb value, 10 to the negative 5th. Still not great, but better than the acid. So the H plus from the HCl takes over. We've got a pH below 7. I'm Smath. I hope this video helped.